Now, next is critical aspect of statistical quality control is evaluating the ability of a production process to meet or exceed the preset specifications. These preset specifications is known as process capability. Okay. These are also sometimes called as the specification limits. The specification limits are larger than the control limits. How does this work? We have some specification limit, like this is the central line, and we have upper specification limit and we have lower specification limit, okay, and we have the upper and lower control limit within them, upper control limit and lower control limit. So, it is such that, okay, it is such that even if the readings or the experiments are done at different times, and the central limit, if you the central line is also varying, but the specification limits are defined, which are given are also sometimes known as the tolerance limits. The tolerance limit that we have seen in the measurement in the tolerances, those are sometimes called as specification limits. So, within the specification limits, our process has to vary. So, process has to remain within these limits. So, it is something like this. So, this can be one time, okay, the other day it could be like this, on the other day it could be like this, okay. So, these specification limits, I will put it, these are specification limits and these are control limits. To understand what exactly process capability means, the term specification needs to be understood. It is the preset range beyond which it wouldn't be accepted actually. For instance, there might be some diameter like 30 centimeters plus minus 0.5. So, this value would be 0. Or this value would be actually 30.5, okay, this would be 29.5 and this value is 30 center line, okay, centimeters, these are specification limits. Now, these control limits can be put such as maybe 0.25 plus minus, or we can define the control limits in a different way. So, but the thing is that within specification limits our process should lie. So, simply setting up control charts to monitor whether a process is in control does not guarantee process capability. To produce an acceptable product, the process must be capable and in control before production begins. So, we can just say that process capability, which is also termed as CP, process capability is equal to specification width and process width. This is equal to specification width by process width. Okay. What is specification width? Specification width is the difference between the upper specification limit and lower specification limit. And the process width that we have picked here, the process width here, this is what is this value? If this is center line of this process, this specific process that we are picking. So, this can be plus 3 sigma, this can be minus 3 sigma. So, this is 3 sigma plus 3 sigma minus 3 sigma, which is equal to 6 sigma. So, this is process capability. Here the value 6 is standard deviation, and the reason we use 6 is that the most of the processes measurement are within 99.74%, that is within plus minus 3 sigma. So, that is why this is generally used. So, the specification width, sometimes the process variability and the specification width may vary. So, the process variability outside the specification limit can also be the cases. Okay, I can put 3 cases here. I have this process, okay, this is minus 3 sigma and plus 3 sigma, minus 3 sigma and plus 3 sigma, minus 3 sigma and plus 3 sigma. So, this is my process variability. Okay. This is my process variability. So, the specification width can be like this. If it is like this, okay, this is lower specification limit and this is upper specification limit, and this is my specification width. Now, this means that the process variability is within my specification width. Process variability is lower. In this case, if specification limit is something like this, it is low specification limit, this is upper specification limit, this is within specification, the previous one is within specification width, okay. This is outside the specification width, okay. In third case, I can take it exact equal. So, these three kinds of cases can exist. This is lower specification limit and upper specification limit, okay. So, this meets the specification limit exactly equal to specification width. So, this is the process capability. Next, I like to talk about the acceptance sampling. Acceptance sampling involves both the producer or supplier of the material and the consumer or buyer. Acceptance sampling is the term used to select the samples out of a given population to do the inspection or to do the quality control. Acceptance sampling is most useful when a large number of items must be processed in a short time. The cost consequences of passing defects are low. Passing defects means passing the defects to the customers. Sometimes acceptance sampling is there. We know we have picked a sample and we are trying to represent the whole population from this sample only. And if the sample is not selected properly, or if I can say, I'll just talk about the producer and the consumer's risk. If the sample is good but is rejected, the producer is at risk. If the whole population is actually good, but the sample that is selected is not good. So, because of the not good sample or the bad sample, the whole population is rejected. That is the producer's risk. The producer is at the loss. So, we can say the producer or the supplier is at the loss here. The consumer can be at the loss if the whole population or the whole lot is bad, is having defective pieces, but the sample that is selected is good, and based on that sample this whole lot is selected and that is passed to the consumer. So, the consumer has received a bad lot, okay, that is the consumer's risk. So, for the cost consequence of passing defects, if they are low, the acceptance sampling is helpful. Then the destructive testing is required. If it is required, okay, then acceptance sampling is again helpful, because whenever we do destructive testing, the sample would be then deteriorated and it cannot be passed to the customer. So, fatigue or boredom lead to inspection errors if census kind of inspection is done. So, we can have various sampling plans. Single sampling plan is a decision rule to accept or reject a lot based on the result on one random sample of the lot. One lot is selected, okay, then we just said, okay, if these many numbers of pieces are defected, we will accept, more than these it will be rejected. This is single sampling plan. In double sampling plan, what happens, two sample sizes are selected. For instance, number of defects can be selected as 3 and 5. If 3 defects are there, or we can say we can select two sample sizes. Okay, in this case, let me say if I have selected sample size as 10 and the number of defects those are accepted are 3. Okay, if out of, okay, 10 is a very small number, I will just put 100. 100 out of 100, 3 defects, if those are there, it would be accepted, more than 3 would be rejected. This is single sampling plan. In double sampling plan, what will I do? I will select a sample of 200 Okay. First I will divide it into two parts. If in first 100 the 3 defects are there, less than 3 defects are there, the whole lot will be selected. If the defects is more than 3, I will inspect the whole 200 and change this number. I will select 5 defects. So in the first step, out of 100, if the pieces are inspected and if defects are found, then we select the other 100 pieces. Okay, this is cumulative actually. So other 100 pieces, the total 200 pieces are then inspected, and if more than 5 defects are found, then this lot is rejected. Okay, this is double sampling plan. Further, we can have multiple sampling plans like this. So further refinement of double sampling plan, there is sequential sampling plan that can be like we can move in sequence. The management can decide whether to conduct a single or double or multiple sampling plans. So in this sequential sampling plan, the consumer randomly selects the item from the lot and inspects them one by one. So this can also be one of the way. So an important aspect in the acceptance sampling is the operating characteristic curve, OC curve that we call. So the probability curve, this probability curve shows that the probabilities of accepting lots with various fraction defectives. So we have this kind of curve here. On the left hand side, we have probability of accepting a lot. Okay, probability of accepting a lot may vary from 0 to 1. Okay, 100% is we are sure that we accept a lot and 0 is there. And this is lot quality, that the fraction of defective. So if the fraction of defectives are more, I can set a few limits here. So this, if I have selected 3%, 3% I have put it my acceptance level. So I will call that if it is less than 3%, this is my good lot, and this rest is my, okay, I will put it here, this is good lot and this is my bad lot. Okay. So this specific limit beyond which the lot is termed as bad lot is called as AQL. AQL, which is acceptable quality level. Acceptable quality level is the percentage of defects at which consumer are willing to accept the lots as good. So 3% accept of defects are accepted by the customer. Like this can vary. This is 3% is selected here. Okay, and on this side the 20% is LTPD. LTPD is lot tolerance percent defective. I'll just put these terms here, AQL, LTPD. It is average quality level. Okay, this is lot tolerance percent defective. This is the upper limit on the percentage of defects that a consumer is willing to accept. This is the upper limit, maximum limit. There is a consumer risk and there is a producer risk. How we can represent that on our OC curve? So we have two kinds of risks here, the producer's risk and consumer's risk. So these are denoted by alpha and beta. So this is the manufacturer's risk. If 0. This is the producer's risk here. What is the producer's risk? Producer's risk is that the probability that a lot containing the acceptable quality level will be rejected. So this was acceptable quality level, but it is rejected, that is producer risk. So I have put a letter bad here. In case of LTPD, the bad value would come here. I'll put it with another color. So this is good if I consider LTPD. This is something in between, and this is bad, and this is indifferent. Okay. So this is producer risk, that an acceptable quality level is rejected. Similarly, we can have the consumer risk. The consumer risk is when the probability that a lot contain defectives exceeding LTPD is accepted. Okay, actually it is exceeding LTPD, but it is accepted. So this consumer risk can be put here. So this is consumer's risk. Okay. So, this is producer risk and consumer risk. This can be termed as alpha and beta. This is alpha and this is beta. So, this value and this value is 1 minus alpha, and this value this is equal to beta. So, this is OC curves. So, we have various points here, AQL, LTPD, alpha and beta. So, okay. So, what is ideal OC curve? Ideal OC curve would be like this, which actually does not exist. So, this is ideal operation characteristics curve. Okay, next is average outgoing quality. So, what is average outgoing quality? It is the average of inspected lots, that is 100%, and uninspected lots. So, average outgoing quality is, I will just put it a relation here, average outgoing quality is given by P into PA into N minus N by capital N, where what is P? P, small p is true proportion of defective, okay, maybe of the lot, and PA is the probability of acceptance. Probability of accepting the lot. So, in capital N and small n, you know capital N is the lot size and small n is the sample size. So, if I try to plot my average outgoing quality, okay, this is average outgoing quality, that is the percent defective, and incoming lot percent defective, incoming lot percent defective. The curve is something like this. Okay. So, it should be within AOQL, like it is my average outgoing quality level, AOQL. So, with this I like to conclude this lecture. So, what I discussed is what is statistical quality control and what is statistical process control. So, I just had a brief introduction about the control charts, then process capability is discussed, then acceptance sampling is discussed, and also I discussed the quality assurance. What is quality assurance? I discussed in the beginning, and how does quality assurance vary or differ from my quality control. So, if I put my quality control and quality assurance here, so what is quality control? It is a set of activities ensuring that quality in the products that focus on identifying defects when the actual products are produced. So, it is after, it is generally before production, okay, just to point out a few differences. And quality control aims to identify or correct the defects. It is for correction, and this is for actually prevention of the defects, because we do a proactive quality process is taken into account. The goal in the quality control is to identify defects, and in the quality assurance we improve the development and test the processes. The goal is here, the goal is to identify defects, okay. Here goal is to improve the development or the quality control process itself, okay. Another difference, I can put the people who are responsible here, the mostly in quality control, a specific team is there, an inspection team, specific team, and here we have generally everyone on the team, that like the whole management. Okay, if not like the upper management, but everyone in the team is involved. Improvement process. So the quality control, the activities or techniques which are used to achieve and maintain the product quality. So that is quality control. So prevention of the quality problems is our quality assurance. So on the final note, I can put that quality control is validation, and quality assurance, that I believe, is verification. Okay. So quality control is a corrective tool and quality assurance is a managerial tool. This difference I would like to incorporate here. So with this, the quality control and the quality control, quality assurance and acceptance sampling, this part is over. So we'll meet in the next lecture where we might discuss the 3D measurements and the coordinate measuring machine. With that, the course would be complete, and we would like to have the questions with you, and please put the logical questions in the forum, and we'll try to answer all your questions and your queries. Thank you.